All right, before we start teaching the new stuff, at the top of your paper right here, we're going to review what we did on Tuesday, okay? So on Tuesday, we talked about the function y equals 1 over x, and we talked about something called the long run behavior. And we said the long run behavior for 1 over x, we have a horizontal asymptote at y equals 0 right here. And we said on the right-hand side of 0, we're going to be above the y equals 0 line. And on the left-hand side, we're going to be below. And that's what we talked about on Tuesdays. Everybody good on that?
Yes.
Okay. Today, here's the new piece, we're going to talk about what we're going to call short run behavior. Today we're going to talk about the short run. And when I talk about short run, we're going to talk about the vertical asymptotes. So I'm going to go ahead and redraw the picture just so you can see it. And I'm looking at this asymptote right here at x equals 0. And the short run for 1 over x, is we're going to draw an arrow going up on the right side of the line, and I'm going to draw an arrow going down on the left side of the line. And that's for a positive 1 over x. If I change this to a negative 1 over x, what's going to happen to my arrows? They're going to switch. So today, when I ask you about long run, you're thinking about the horizontal and if we're above or below. When you ask you about short run, you're thinking about the vertical and am I going up or am I going down? That's for 1 over x. We also talked about another function. We talked about 1 over x squared. So let's go review that one because we'll see that one today too. We got y equals 1 over x squared. The long run behavior for y equals 1 over x squared is both the right and the left are above the horizontal asymptote. So they're both above. This is our long run. The short run, and this is the new piece today, the short run for y equals 1 over x squared is going to be focusing on our vertical asymptote at x equals 0. And they both go up on the left and the right of that line. So 1 over x, long run, right side up, left side down. Short run, up on the right, down on the left. That kind of seems similar. Okay. 1 over x squared, long run, they're both up above the horizontal asymptote. Short run, both lines go up on the right and the left-hand side. So when we're doing this worksheet today, a lot of it is going to be reviewing what we did Tuesday while we learn something new. Some of it's going to seem really easy. Some of it's going to get a little bit more difficult. You might even want scratch paper today, but that's up to you. All right. Because I know what problems are easy versus which ones are hard, I am skipping 1, 2, and 3 for now. Because if there was something you had to do on your own, those were the 3 you'd want to do on your own. Let's go ahead and skip right to number 4. Okay, on problem number 4, they asked me to do the long run behavior, they asked me to do the short run behavior. So we're first going to review what we did Tuesday, and then we're going to talk about the new stuff. All right, so review from Tuesday. If I asked you to go reduce your leading coefficients, and I'm only looking at the leading ones, it would reduce to 1 over x. That means this equation, long run, is going to behave like a 1 over x. This is what we did Tuesday. I didn't have to do any dividing right now. So since I didn't divide, the asymptote stays at y equals 0. So we're going to go graph my horizontal asymptote at y equals 0. And because it's going to behave like 1 over x, on the right side of 0, I'm going to be above the asymptote. And on the left side of 0, I'm going to be below the asymptote. And then we're going to write our behavior statement. So let's make sure that we all understand this from Tuesday. As x goes to the right, which means positive infinity, my graph is going to be above this 0 line. Remember, we do above with a little plus sign. And then as x goes to the left, which is negative infinity, my graph is going to be below the 0 line. And we put a little negative to represent below. So that's a review from Tuesday. What questions do you have? All right, so everybody feels comfortable? We're all caught up? All right, so the new piece today. When we talk about short run behavior, we're focusing on the bottom. We're focusing on just the denominator. And I want to know what would make this denominator equal 0. So what would make x plus 4 be 0 if x were what number? Negative 4. So my vertical asymptote is negative 4. And then they ask me what it's going to look like. To figure out what it's going to look like, you have to take this answer that you just got, and I have to go plug it into this equation everywhere I see an x, except where I see x plus 4. Are there any other x's to plug into? No. That means it's going to behave like exactly what it says, x plus 4. Okay, this is a positive 1 over x plus 4. Because it's a positive, I'm going to go up on the right side of the asymptote, and I'm going to go down on the left side of the asymptote. And I'm drawing arrows there to help me remember. You don't have to do that. It's just something I like to do. So I'm going to go draw a line at x equals negative 4. 1, 2, 3, 4. Excuse me. Okay, so here's the big picture. I'm looking at this vertical asymptote right here. And it says over here in my directions that I want to go draw an arrow going up on the right side of this line. So here's the right side, and I want an arrow to go up. And then it says I want to go to the left side of that line, so way down here, and I'm going to draw an arrow that goes down. The new piece is going to be right in the behavior statement. Okay, this time we're approaching this vertical line. And this vertical line is negative 4. And I'm going to approach negative 4 from the right and the left. To approach it from the right, I put a little plus sign up here. So this says as x goes to negative 4 on the right. So as I go this way, which way did I draw my arrow? Up. And the way we write that is we write f of x goes off to positive infinity. Positive infinity now means going up. And then we're going to go over here on the left side of negative 4. As x approaches negative 4 from the left, I put a little negative guy there, we drew an arrow that went down. So I'm going to write negative infinity. We're not going to do these test points today. You can scratch through those. Do I have anything else in my denominator other than x plus 4? Nope, so that means I don't have a second vertical asymptote. And before I can go sketch my picture, I need to go find key points. X-intercepts, y-intercepts. So the y-intercept is always the easiest one to find. I like to do that one first. So y-intercept, let x equal 0. So here's my equation. Y equals 1 over, in place of the x, I'm going to put a 0. So I get 1 over 4. So my y-intercept is at 0, 1/4. So I go to 0, 1/4, which is going to be really close to the 0 line. I put a dot. What is my x-intercept going to be? When am I ever going to touch this line? I'm not. So my x-intercept does not exist. Because there's an asymptote right there. Okay, so now I can go sketch in my picture. Now I can tell you on a scale of 1 to 10, 1 being the easiest problem and 10 being the hardest, this was a 1. This is a 1 because you probably could have given me this exact picture without doing any of this work. Because you already know what a 1 over x looks like, and you already knew that this should have went left 4. So this should not have been a surprise. Here's the deal though, on your test, instead of giving you this equation, what they're going to do instead is they're going to just give you this statement. They're going to give you the long run behavior and the short run behavior, and then they want you to go pick the right graph. So you have to know what these mean. Okay, questions on what either one of those mean? Carissa? Okay, so let's turn the page and let's go look at number 5. On a scale of 1 to 10, 10 being the hardest, I would say number 5 would run about a 3 or a 4. Okay, the math isn't hard, but what do you notice on this one? There's 2 asymptotes, so it just means I have to do more stuff. The math isn't hard, it just takes longer to do the problem. Okay, so we're going to focus on the long run first. To do the long run, I have to take the ratio of the leading coefficient on top and the leading coefficient on the bottom. So on top, I have a 10. Be careful. What is my first term on the bottom really? What do I need to do with those numbers to figure it out? It's x squared. I have to FOIL it. But do you need to FOIL it all the way out? No, you just really need to do those first 2 terms. So x times x is x squared. So a 10 over x squared is going to look like a 1 over x squared. And since I didn't do any division, I know I'm going to have y equals 0. So I'm going to go graph my picture. I have a horizontal asymptote at y equals 0. It's a positive 1 over x squared, so I know I'm going to be above this line on the right, and I'm going to be above this line on the left for both. So we're going to write that using our notation. As x goes off to positive infinity, my function is going to be above the 0. And as x goes off to negative infinity, my function is still going to be above the 0. Remember, when you're doing long run behavior, whatever number they give you, that's your horizontal asymptote. And they're telling me I'm going to be above on both. Alright, so let's go do short run now. On the short run, you already told me you realize that we're going to have 2 different asymptotes. So let's just focus on the x plus 2 first. If I asked you what's the asymptote at x plus 2, you're going to tell me it's x equals what number? Negative what? 2. Very good. We're going to start with negative 2. This is the first time we're going to actually have to do work for what it looks like. When I ask you what it looks like, you have to go to this equation and plug negative 2 into every x except the one with the 2. If I plug into the 2, I get 0, so it doesn't help. So I'm going to go do more work right above my table, right here. So I've got y equals 10 over, I just bring down the x plus 2, and then I'm going to go plug 2 in right here. So I've got negative 2 minus 3. What is negative 2 minus 3? Negative 5, good. And what is 10 divided by negative 5? Negative 2. So this is going to look like a negative 2 over x plus 2. The only thing I really needed was the negative. That negative tells me which way my lines are going to go on the right and the left. Because it's a negative 2, on the right side of my vertical asymptote, I'm going to go down, but on the left side, I'm going to go up. Okay, so let's go graph what we just said we're going to do. So I need to go graph a vertical line at x equals negative 2. And we just wrote down the directions. The directions that we wrote down were on the right side of that line, draw an arrow that goes down. On the left side, draw an arrow that goes up. So over here on the right, I'm going to have a line that goes down. On the left, I'm going to have a line that goes up. Okay, now we're going to go write what we just drew. And that's the hard part because it's only because it's new. So this line right here is -2. So as x approaches -2 from the right, I put a plus. On the right side of this line, I drew an arrow that went down. So we write f of x approaches -infinity because I went down. As x approaches -2 from the left, I put a little negative up there to mean left. My line went up, so I write positive infinity. And we're not doing test points. It's not that we can't do it, it's just a time thing. We just take points and we plug them in to see what happens. Okay. We have a second asymptote I have to go look at. So the first one we looked at was x plus 2, so now we're going to look at the x minus 3. So what would the asymptote be at x minus 3? X equals positive 3. Very good. So now we've got x equals positive 3, and that doesn't show up very well. And I have to go plug into my original equation to every single x except the one that's got the 3 in it. So y equals 10 over 3 plus 2 x minus 3. Now what's 3 plus 2? 5, and 10 over 5 is really 2. And I really just care about the sign. It's a positive on top. So it's going to look like a positive 1 over x. So it's going to go up on the right, down on the left. Okay, so I go to my graph. Everybody ready for the graph? And on the graph, I go draw my line at x equals 3. And you just told me that on the right side of this line, I'm going to go up, but on the left side, I'm going to go down. Okay, now I'm going to go write what we just did over here. As x approached 3 from the right, I put a 3 with a plus sign. I drew a line that went up, so I put positive infinity. And as x approaches 3 from the left, I'm going to draw a line that goes down, so I write negative infinity. We gotta go find our key points. I need to find an x-intercept and a y-intercept. All right, look at my picture. What will I not have? What will I never ever touch because there's an asymptote there? I'm never going to touch this line right here. What axis is this? Is this the x-axis or the y-axis? This is the x-axis. So x-intercept does not exist. And I can tell that by looking at my picture. I could go do the work, but I'd still get the same answer. Now I'm going to go find my y-intercept. Remember, you're going to let x equal 0. So my original equation says y equals 10 over, so if I go plug in a 0 right here, what's 0 plus 2? 2. What's 0 minus 3? Negative 3. So I've got 2 times negative 3 on the bottom, which is equal to 10 over negative 6, which reduces to negative 5 thirds. So my y-intercept is 0, negative 5 thirds. Okay, so now you got to do some math, some thinking. Without a calculator, you can do this. What would negative 5 over 3 be really close to? Very good. It's really close to negative 2, but not quite there, but really close. So right above the negative 2, I'm going to go put a dot. Okay, so let's take a step back and look at this picture. On the right side over here, I can tell that I have my normal curve that I always get. And I can tell that I have my normal curve over here on the left that I always get. So it looks a lot like the 1 over x squared, just like I thought. But then you probably would have never guessed in a million years that you would have had an upside down parabola in here also. The only reason we know that that exists is because we did our short run behavior. Questions? Okay. Let's go ahead and look at number 8. We're going to skip 6 and 7 for right now. If we have time, we'll come back and do them, or we can do them tomorrow together. But right now, we're going to go ahead and jump to number 8. Number 8 is a doozy. There's lots of work to do. None of it's hard. But if I had to rate this one on a scale of 1 to 10, this is going to be more the 6, 7 range. Not because it's super, super hard, but there's a lot of work to do. Okay, so we ready? To find the long run behavior, the first thing you have to do is I have to get the ratio of the top and the bottom. Before I can get the ratio, what do I have to do to the top?
Multiply.
You have to multiply. I got to FOIL it. Okay, and I'm going to ask you to trust me. When you FOIL this, we get 2x squared minus 10x plus 12. So if I were to take the time to do the FOILing, that's what we'd all get. And that would all be over x squared minus 2x minus 3. Now when we did this on Tuesday, I said always look at the first two numbers and see if you can reduce. If I reduce these two, do I get a 1 over x or a 1 over x squared? You don't get either. And if you don't get either, what did I tell you you have to do? You have to divide. Okay, so if you have scratch paper, this is a great time to pull it out. You don't have to. A lot of people in my other class did it right here. They just turned their paper sideways and did their division right here. Okay? All right, but I'm going to make sure y'all can see it. If I were to do it sideways, it's too small for y'all. All right, so we're going to go divide x squared minus 2x minus 3 into 2x squared minus 10x plus 12. All right, so you're looking at your first number. How many times will 1x squared go into 2x squared?
Twice.
Twice. So 2 goes on top, and then I have to multiply all these numbers by 2. So I get 2x squared minus 4x minus 6, and then I subtract. Okay, when I subtract, the 2x squareds go away. Negative 10 minus a negative 4 is negative 6x. 12 minus a negative 6 is positive 18. Okay, now we have to go write down what we just got. We write y equals negative 6x plus 18 over x squared minus 2x minus 3 plus 2. Remember, your remainder becomes your numerator. What you divided by becomes your denominator. That's what we did on Tuesday. Okay, and then I said, okay, now we're going to go look at our leading coefficients again. What is that going to reduce to? A 1 over x or a 1 over x squared? What kind of 1 over x, though?
Negative.
Okay, so we had to do all that work so I could answer this question right here. It's going to look like, oh, sorry, thank you. Whew, saved me. It's going to look like a negative 1 over x. But this is all the scratch work we had to do. Okay, that's why this problem is like a 6 or a 7 or an 8, because of the amount of scratch work we had to do. Because I divided, the asymptote is not going to be at 0. Where is my asymptote at? It's at 2. Very good. It's that number that we plus at the side. So we're going to have y equals 2. So now when I go graph this one, I'm going to have a line at 2. And it's going to look like a negative 1 over x. So it's going to be below this line on the right, but above this line on the left. So as x goes to the right, I'm below 2. And as x goes to the left, I'm above 2. Are there any questions on the division or the reducing or any of the stuff that we did Tuesday? Okay, because it's about to get ugly. You all ready? All right. Again, the math isn't hard, but this is going to require more scratch work on this problem. To do short run behavior, I need everything factored. To do long run, you got to FOIL it. To do short run, I need it factored. So over here to the side, I'm going to write down what I'm going to be using to do the whole short run. So I'm like the top the way it was. The top was fine, so I'm going to go rewrite it. Y equals 2 over x minus 2 and x minus 3. And the bottom, what factors of negative 3 add up to negative 2? What factors of negative 3 add up to negative 2? Very good, negative 3 and 1. Okay, so here's something that's going to happen. I don't know if you remember this from Algebra 2 or not. Do you see how these right here are going to cancel? When they cancel, it creates something. Do you remember what it creates? Okay, it's going to create a hole in your graph. So we're going to have a hole in the middle of our graph. Your hole is going to occur at the value of x that makes this 0. What value of x will make this 0? 3. So the x is going to be 3, but I need to figure out what is the y going to be. To figure out the y, you have to take this 3 and plug it into the other x's. So to figure out the y, you have 2 times 3 minus 2 over 3 plus 1. I went to these x's and I plugged in 3. What's 3 minus 2? 1 times 2 is, and what's 3 plus 1? So the y value is 1/2. There is going to be a hole on our graph at 3, 1/2. You're only going to have a hole or a point of discontinuity, that's what they like to call it, a point of discontinuity when something cancels on the top and the bottom like that. Okay? So let's go ahead and put that hole in our graph so we don't forget. So I'm going to go to 3, 1/2. So 1, 2, 3, 1/2, and I'm going to draw a hole at 3, 1/2. I put a little hole at 3, 1/2. Everything else that you do on short run is only going to be using this part of the equation right here. You ignore where the hole is now. I'm only going to focus on this piece now. So if I'm only focusing on that piece, how many asymptotes will I have vertically? 1. So we're going to have an asymptote at x equals -1. Okay, to figure out what it looks like, I told you earlier, you have to go plug in -1 everywhere but in this one spot. Well, do I have something to plug in on top? Oh man, the work never ends. Okay, so I gotta go plug that -1 right there. So I'll come do it over here. So I have 2 parentheses -1 minus 2 all over x plus 1. What am I going to get on the top? What is 1 minus 2? Times 2 is going to be, it's going to look like a -6 over x plus 1. The only thing important is that negative sign, which tells me I'm going to go down on the right, up on the left. That was the whole thing that I had to pay attention to, the positive or the negative. Okay, so now I go to my picture, and I'm going to go make my line at x equals -1. And I'm going to remember that on the right side of this line, I'm going to go down. But on the left side of this line, I'm going to go up. Okay, before we can actually sketch it in, we got to go find our important points. One of my important points I wanted was a hole. Did I already find that? Okay, so we said at 3, 1/2, we have a hole. It's the first time I've had one, but we do have one. I need to find my x-intercept and my y-intercept. The y-intercept is always easiest, so I'm going to find that first. Okay, to find your y-intercept, I got to come back up here to my original equation, this one right here. And I'm going to let x equal 0, so y equals 2 times, what's 0 minus 2? Negative 2. What's 0 minus 3? Negative 3. Over 0 squared minus 2 times 0, that's all 0, minus 3 is negative what? 3. So I need to know what that number is. What is 2 times negative 2 times negative 3 divided by negative 3? Negative 4. So my y-intercept is at 0, negative 4. So at 0, negative 4, I want a point. 1, 2, 3, 4. This is the first time that we have to find an x-intercept. When you're looking for the x-intercept, I like to plug into the easiest equation I have. And the easiest equation I have is this one right here. That's the one I'm going to solve for because that's the nicest one. So the equation says, I'm going to let y equals 0 to find the x-intercept. I'm going to have 0 equals 2 times x minus 2 over x plus 1. Yeah, and the y equals 0 when you're looking for an x-intercept. So I got an x on the bottom. What do I need to do to get rid of that? Yeah, I got to multiply both sides by x plus 1. So I'm going to write that in yellow. And over here. Now when you multiply x plus 1 on the left, since you're multiplying by 0, what does it stay? 0. And when I multiply on the right, these two cancel, and I just have 2x minus 4. Does everybody know where I got 2x minus 4? And then you just solve. Y'all can solve that. That's not a big deal.
Why are you multiplying x plus 1 on...
Both sides?
Yeah.
Because it's in the bottom, and the only way to pull it up to the top is to multiply both sides by it. Good question. All right, so now I'm going to solve. I'm going to add 4 to both sides and get 4 equals 2x. So x is going to equal 2. So I'm going to have an x-intercept at 2, 0. So 1, 2, right before the hole. Okay, so now I can go sketch what my picture is going to look like. I'm going to approach that hole. Questions? And I know I'm not under any illusion that this is something that you want to go do on your own. I know this takes a lot of time and it's a lot of brain cells. But it is still good for you to go try, even if you don't want to. All right, let's go look at one from the front now, just so you can see what one of those would look like. Let's go look at number 1. Now that we've done a lot of this, I think the front will actually make sense. This is more like what you might see on a test, but you had to do all of that to understand what this is saying. They are telling you that you have a long-run behavior that goes off to the right. Remember, this little piece right here means you're moving to the right. So this means as I move to the right, I'm going to be above or below the 2 line? Above. So I know that that means I'm going to have a line at 2. And on the right side, I'm going to be above it. That's what that statement's telling me, and that's what you have to be able to figure out. So how to read it backwards. And I know as I go off to negative infinity, which means the left of my graph, that I'm going to be what? Above again. Ooh, what does that tell me then? If I'm above, it's going to be a 1 over x squared something, right? Or that's how it's going to behave. So I'm going to make a little note to myself right here. This is a 1 over x squared with a plus 2 because I have an asymptote at plus 2. That's something I figured out just from this statement. Okay, now I'm going to go look at my short run. My short run's going to tell me about my vertical. Where did they tell me I have a vertical asymptote at? At 3, and I only have how many? 1. I only have 1 vertical asymptote, and they're telling you that it's at 3. So this right here, this number is going to give me my vertical asymptote. So 1, 2, 3. And it's got a 3 with a plus sign. That means on the right of the 3, I'm going to infinity. Does that mean I went up or down? Up. So to the right of this 3 line, I went up. And the next statement says, to the left of the 3 line, I went down. So now that I kind of have an idea, it's not perfect, it's just an idea of what it looks like, I should be able to look at these answer choices and pick the one that's most possible. Yes, sir? I'm not. Does it say go up? Did I look at it wrong? Oh, you're right. It does. My fault. It does say go up. It's because I have old eyes. Thank you, Louise. Okay, and that makes more sense because we have an X squared. Okay, so I'm going to go look at this first answer choice right here, A. It says I'm going to have a horizontal asymptote where? At 3. That's not it. B says I'm going to have one at 2. C says I'm going to have one at 2. And D says I don't have one. What's the difference between B and C? The squared one. Which one do I want? Squared. Okay, I know I've left you with a lot of problems to do. If you are here tomorrow, we'll do more tomorrow together. Okay? If you're not here tomorrow, watch the video that I'm going to put up today after school, and where I'll do some more with you. Everybody good? All right.